Imagine a universe where everything boils down to just one possible state. How could we, as observers, even exist in such a reality? This mind-bending question lies at the heart of a groundbreaking new quantum gravity paper that's sparking intense debate among physicists and philosophers alike. But here's where it gets controversial. The authors toss in a footnote that cheekily invites readers to ponder the theological implications, a move that's sure to divide opinions on whether science is encroaching on spiritual turf. Let's dive into this fascinating preprint and unpack what it means for our understanding of the cosmos, step by step, so even newcomers to quantum physics can follow along. Quantum mechanics and general relativity stand as the towering achievements of 20th century physics. In their own domains, these theories have proven remarkably accurate through countless experiments and observations. Yet, they reveal their cracks when we try to merge them, particularly in extreme scenarios like the interiors of black holes or the fiery origins of the Big Bang. These are places where the rules of the very small, quantum effects, clash violently with the rules of the very large, gravitational forces, leaving scientists scratching their heads. The quest for a theory of everything, a unified framework that blends quantum reality with gravity, remains one of the biggest challenges in physics. Several contenders are in the running, each pushing the boundaries of our knowledge, though most are still too abstract to test directly. For instance, we can probe quantum mechanics or relativity separately, as seen in recent detections of gravitational waves from colliding black holes, which beautifully confirmed Einstein's predictions. But a full reconciliation? That's the Holy Grail. Leading the pack are ideas like string theory and loop quantum gravity. String theory proposes that fundamental particles aren't tiny dots, but vibrating strings, with their characteristics emerging from those vibrations, like how different notes on a guitar string produce different sounds. On the other hand, loop quantum gravity suggests space isn't infinitely divisible but composed of tiny, interconnected loops, similar to how pixels build up a digital image. And the field doesn't stop there. There are even bolder approaches, such as theories where gravity emerges from entropy, treating it as a byproduct of information flow rather than a fundamental force. These concepts rely on rigorous mathematics to tackle the quantum gravity puzzle, and now, enter this exciting new paper. Authored by Daniel Harlow, Mykhaylo Usatyuk, and Ying Zhao from MIT and the Kavli Institute for Theoretical Physics, it's a preprint awaiting peer review. The focus? The Hilbert space in quantum gravity. Think of Hilbert space as an extension of the familiar 3D Euclidean space we use for geometry, but expanded into infinite dimensions to handle quantum possibilities. When applied to a closed universe, one that might eventually collapse back into a big crunch, something astonishing occurs. In such a setup, the potentially infinite-dimensional Hilbert space shrinks to just one dimension. The key ramification? A closed universe like this couldn't support an external observer, someone outside looking in. This is the part most people miss, as it flips our intuitions about reality upside down. Without an external viewpoint, how does observation, a cornerstone of quantum mechanics, even make sense? Physicist Brian Cox, known for his accessible explanations of complex science, raved about this paper on social media. He called it exhilarating to read, especially if you're into quantum gravity, black holes, or holography, and highlighted its famous footnote. We leave the theological implications of this statement as an exercise for the reader. Cox's enthusiasm underscores the paper's provocative edge. It's not claiming to prove or disprove any divine overseer, but it does explore how observers like us could fit into a one-dimensional universe. Drawing on holography principles, where a 2D surface can encode all the data of a 3D object, imagine a hologram that captures a full room in a flat image. The authors suggest ways to embed human-like observers within this constrained framework. And this is the part most people miss. While the paper doesn't fully unify relativity and quantum mechanics, it opens doors for applications in black hole physics. For example, it might help explain the information paradox, why data seems lost forever in black holes, despite quantum rules saying otherwise. Even if it doesn't revolutionize everything, that footnote alone is likely to become legendary, blending hard science with philosophical musings. The preprint is available on AR-14 for those eager to explore the technical details themselves. But what do you think? Does this paper's implication that a one-dimensional universe negates external observation challenge our notions of reality, or does it subtly nod towards something more metaphysical? Could this be a step toward reconciling science and spirituality, or just clever wordplay? Share your thoughts in the comments. Do you agree with Cox's excitement, or see it as overblown? Let's debate this cosmic conundrum together.